Hello guys, my name is Balkrishna Shivastav and welcome to Code with BK. So in this video, we look at the differences between struct object and struct pointers in C programming, and we see what are the common mistakes that usually happen when you try to work with struct objects and struct pointers. So before we begin, it is a request to please subscribe to my channel. So if any of my previous videos has helped you out, or if this video helps you out, so please do subscribe to my channel. Okay, so when you're learning C programming, you have a C programming course or you are working at a C programming project, there are very high chances that you come across struct objects and struct pointers, because C is not object oriented programming language, right? So struct is a way to put multiple data types together in one single unit and move it around. Okay, and pointers make that a little more easier, but then pointers are complicated to understand. I won't say it is complicated, but it does need a little more detailed understanding than other concepts, other regular concepts of programming. Okay, so suppose if we have a struct point, okay, I'll just take two integer variables inside, int x and int y. Okay, so there can be a case where we have a pointer inside this struct, and we look at that in the later videos. Okay, so if I create something like this, struct point o1, okay, and I do something like this, struct pointer p1. Okay, so these are two different things. This is a struct value, or I'll say struct object. Okay, I don't want to use the word object in C programming because you don't have objects in C programming, but this is what comes closest to what how actually a struct is stored. Okay, so suppose if I have int k and if I have int star p. Okay, so this is a value, this is a pointer. So this you can call struct point a struct object or a struct value. I'm going to stick with struct object. Okay, just to refer to the struct that this o1 is storing. Okay, and this is a struct pointer. Okay, struct pointer. Okay, now struct point o1 basically gets memory to store x and y values. This pointer gets memory to store an address where a struct is stored. How? So when I have to do say equal to 10, okay, so this is a value, and if I say int star p equal to ampersand k, okay, this is a pointer. Okay, so I've discussed this in detail in my previous video where I tell what are pointers, but still I'm going to take a recap. So when you do something like this, right, so if this is your memory, okay, where your variables and stuff are stored, you say int k equal to 10, so you get memory enough to store one integer because the type of this variable is int. Okay, so which is 4 bytes. You don't have to worry about what is the number of bytes that is needed. You just have to understand that when you do something like this, okay, you tell the compiler, okay, k is a variable of type, so you give memory enough to hold an integer, and the value it is holding is 10. To hold an integer, an int value. Okay, the value it gets is 10, and the name of the memory location, or you can say the variable name is 10, is k, and it is of type int. Okay, when you do this, this is also very similar to this. Think of pointers in terms of variables with values, just that the type of it is int pointer. Okay, the type of this variable is int pointer, just as the type of this variable k is int pointer, that is it is capable, it gets memory to store the address where an integer is stored. So when you do this, okay, p is a variable, okay, of type int pointer. Since it is an int pointer, it is getting memory enough to store address of where an integer can be stored. Okay, so the variable name is p, and the value it stores is an address of a memory location. Okay, holds memory enough where the value it stores is the address of a memory location, and in this case it is the address of this k. So if this is at addr1, if the address, some hexadecimal value which I'll show and print right now, is addr1, p stores addr1. Okay, pointer stores the address where an integer is stored because it is of type int pointer, so it is a pointer to this variable k. Right, so if I print the value k, print f k equal to %d\n k, okay, and address of k, okay, is going to be %p and p. Okay, so compile and run. Okay, so address of k is basically some hexadecimal value. So every memory location has some hexadecimal value, and address of k, wherever k is stored in the memory, the address of that memory location is this hexadecimal value. The 0x means that this is a hexadecimal value. We have 0b for binary value, 0x to indicate it's a hexadecimal value, and this is the address where this k is stored. Okay, so this is also a variable with a value. So when you are comparing these two, think also in the same terms. This will store an entire struct object that it has its x and y components. This will store an address. Okay, stores address where a struct can be stored. Okay, all right. So when you want to dereference the pointer, okay, you say k equal to %d and you say % and p. Okay, you get 10 in either cases, right? Okay, if I set this value at this pointer, so say 100, now k becomes 100, so k and value at p both become 100. Okay, so last two outputs are going to be 100. Okay, because I'm manipulating the value which is stored at this address p, which is shown here. Okay, so before we move on to struct object versus pointer, I hope this part is clear. Okay, that pointers are also variables with values. The value that they store is basically an address. Since p is an int pointer, it stores the address where an integer is stored. We have double pointer, we have char pointer, we have float pointer. They store an address where the corresponding value is stored. Okay, and they are variables with a value, and the value that is stored is the address of a memory location. Just remember that. Okay, so when we do this, so compare this line and this line. Okay, in this line we have the type of the variable as int, the name of the variable as k, storing the value 10. In this case also, the type of the variable is struct point. It has a type, it has a variable name, but it does not it is not initialized with the value, just as you can do something like this. J has some garbage value. So if I print j, okay, we'll have some garbage value. Okay, j is some garbage value. And what do I mean by this is, when you do j, okay, you get again memory to hold an integer. Okay, the name of this variable is j of type int, but we don't know what is inside. That's why we get a random value here. Okay, could be any garbage value. Okay, similarly, when you do this, very similar to this variable can store a struct, so it gets memory to store a struct. So if we have x and y in our struct, okay, x is some value, y is some value in this case, okay, and the variable here is o1 of struct point. Okay, so just as int j, when you do j gets memory to hold an integer, you don't know what is inside, but it does gets its own memory, right? Similarly, when you do struct point o1, gets its memory to store a struct which has x and y components, you don't know what values are inside, and this is the name of the variable. Okay, so this is just a variable that can store an integer. We don't know what value is there, some garbage value which we saw. Okay, similarly, this is also a variable of type struct point. We don't know what values of x and y inside has. It has some garbage value, but it is a struct. So if you try to print x and y of o1, o1 dot x, we can say o1 dot x, and similarly we can say o1 dot y. Okay, we don't know what values, some values. Okay, so you see, j has some garbage value, x has some garbage value, y has some garbage value, could be anything. So if I run this again, okay, you see the value changed, could be anything. All right, okay, but this means that this variable is storing a struct which is shown here. Okay, it does have its x and y component. When you do something like this, okay, it means we have a pointer and pointer store addresses. So when you do something like this, you get a variable p1, okay, memory enough to hold address of memory location where a struct can be stored. Okay, but we don't know again what value is inside. Okay, this is a struct pointer. Okay, o1 will store a struct. This pointer p1 okay, will get a memory enough to store an address where a struct can be stored. Okay, and we don't know what value inside. So since we don't know what value inside, we don't know what memory address it is pointing to. So if we try to assess the values within this, high chances it is gonna crash. So if we say, okay, o1.x using the pointer dereferencing, we say p1 and we say p1, okay, and we say p1.x and p1.y. okay, this is gonna crash, okay, because this is uninitialized, just as this is initialized, but it is storing some value that we can print. When this is initialized, when a pointer is initialized, we don't know what hexadecimal value it is storing. It is storing some hexadecimal value pointing to some location, we have no idea. Okay, so it is high chances it is gonna crash. So compile, and when I run, okay, I do get some value, but it will not always be the case because this is a pointer pointing to an address. Okay, this case uninitialized pointers are called wild pointers. Okay, in this case it does not crash, but in most of the cases, in high chances, it is gonna crash. Okay, it is gonna give you a segfault because you are trying to point to a memory which is not storing a struct. So right now it is storing some address, but we are not sure which address, and that is the difference between O1 and P1. This is the pointer storing an address where a struct can be stored, and this is O1 storing a struct. Okay, so it has its x and y components. P1's x and y will mostly gonna crash. Okay, or you can say the other words is not properly initialized. Okay, so you either set this to null or you make it point to an object. Okay, so you can say P1 is address of O1. So when you say this, then this is a point, it becomes a pointer to this if you say this. Okay, so then P1.x and P1.y will give you the same value as O1 x and y. So when you do this, so O1 x and y and P1 x and y basically going to be giving you the same value because P1 is a pointer to O1 in this case. Okay, stores the address where this O1 is stored. Okay, and when you initialize this, you say O1 equal to say 3, 4. Okay, now we get correct values for all the 4 cases, your O1 and P1. Okay, so O1 3, 4 and P1 3, 4. Okay, because in this case what you did was you said this is now 3 and this is now 4. P1 is a pointer to this. P1 stores the address. Suppose the address where O1 is stored is say ADDR2. So this will store now ADDR2. Okay, all right. So never use wild pointers directly. You just provide it a memory or make it point to an object. So we are making point it to an object or provide it dynamic memory. You can say P1 is struct point pointer malloc. Oh, I have to include malloc stdlib malloc size of struct point. Okay, right, all right. In this case, high chances, so I'm not going to do this, I'm going to remove this. Okay, when you remove this, this is gone. Okay, this is still storing question mark. Okay, high chances, okay, referencing x y of P1 is going to throw a segmentation fault that is gonna crash. Okay, because this is not, we have not made it point to a struct object yet. It can store an address of a struct object, we are not making it point yet. Okay, right. When we do this, okay, we remove the possibility of throwing a seg fault. Why? Because P1 is now pointing to some struct. Okay, we don't know the values of x and y inside. X and y will be garbage values, but will be some struct, just as in this case when we had this uninitialized. Okay, it was a struct with its x and y components. We just did not know what values inside. You can set the values inside o1.x and o1.y. Okay, but we knew it is a struct. Okay, has its x and y components. Okay, initializing this in this way. So now at least we are sure that it is pointing to a struct. If you print this, okay, it is not gonna crash. Okay, so printing x y components will not crash the program, will just print garbage values. Okay, because we are providing p1, we are making p1 point to some struct object, but we are not just setting x and y of it, we are just making it point to a struct, just as in this case when this was initialized. Okay, and because we don't know what mem location p1 is pointing to. Okay, so now when we compile and run, okay, we get some garbage value which is x00 in this case. Okay, some garbage values. Okay, and then you can set p1 dot x is say maybe 100, p1 dot y is say 200. Okay, and then you print this again. Oh sorry, let this just initialize and print. So p1 dot x and p1 dot y is 100. Okay, so when you are doing this, okay, right now we had o1 and p1. o1 had x and y 3 and 4. Okay, and then we had just had p1. So this is a variable with just question mark inside. When you do this, you are making it point to some struct. Some struct was given in memory which has its own x and y components. Okay, some value. Okay, which we printed, we got some 0 zeros, right? Then we set p1 dot x and p1 dot y using arrow operators to assess x and y components. So if this struct is stored at addr3, this location stores the value addr3. So this p1 now is a pointer to this struct. We don't have a variable directly for this struct, just as in case of o1, but we have a pointer to this struct. Okay, so when you set x to 100, this becomes 100 and this becomes 200, and that is what you print. Okay, so I hope you understand the difference between struct object and a struct pointer. When you have a struct object, it will get memory for all its members. So this point has xy. If it has z, it will get a memory to store xy and z as well into one unit called struct. Okay, when you have a struct pointer is basically a variable that can store an address of a memory location. In this case, the memory location of a struct. And in this case, it is uninitialized. It is not initialized properly. So it has some garbage value. Okay, we don't know it is which pointer it is pointing to. So either set it to null, okay, or make it point to some struct object. Okay, and when you allocate memory dynamically, you free the memory as well. Okay, so you guys won't see any difference in the output, but there are no memory leaks in this case. Okay, because if you are allocating memory to a pointer dynamically and you are not freeing it, you have memory leaks. Okay, because that memory is not returned to the heap. Okay, you should not have that. You should not have memory leaks. Okay, and you can compare it in this terms. You can say int, okay, int p2. Okay, so this is an int pointer. Let me just put it here. This is an int pointer, right? Now this is a variable of type int pointer capable of storing, gets memory enough, capable of storing address where an integer is stored. What address it is storing, we don't know. So if you have this, okay, int p2, the variable name is int p2 of type int pointer storing some address. So if you dereference it, it is storing an address. We don't know what address. It might be pointing to an integer. It might not be pointing to an integer. So if we dereference this value at address stored in int p2, value at address stored in int p2, we have no idea what we get. It might crash. We might get some random value. Okay, this is because this is a void pointer as well. It gets some random value. It does not crash. Okay, but it can crash as well. High chance is gonna crash. Okay, so this is void pointer. Okay, not initialized. We have no idea what memory location this is pointing. Okay, so again you do int say L equal to 20. You make int p2 point to the location of L. So now you get 20 because you are sure it is pointing to this 20 int L. So what happens is basically you get 20, the variable name is L of type int. If this is at addr4, okay, at addr4, so this stores addr4, so this is a pointer to this integer. Okay, or you could also do int p2, okay, give it memory dynamically. Okay, since it is an int pointer, give it memory to store an integer. Okay, right? So again, it gets memory to store an integer. What integer we don't know. It is 0, but what integer we don't know. We can set this integer, say maybe 90. Okay, because we are very sure now that it is going to point to an integer, because we are setting the address in this variable to a memory location that has an integer. Okay, so surely pointing to an integer in this case. So all right, prints 90. All right, and again you'll have to free int p2. Okay, so you see there is no difference in the output, but there is no memory leaks as well. And whenever you free a pointer, I also do this, and I recommend this, and it is recommended in multiple references as well. You set this pointer to null. Okay, that is not pointing to anything. Okay, stores no memory address. Okay, when you do this thing, you're not setting it to null, it is storing some memory address. Okay, and obviously if you set it to null and then you dereference it, you're obviously gonna get a seg fault. All right, so the idea of telling all this was that if you create a struct something like this, okay, initialized or not initialized, the type is struct point. Okay, you get memory to hold a struct which contains all its individual members, and they all get a memory, okay, to store the corresponding values. What values are there, we don't know. If you initialize it, okay, it gets initialized with these given values. If you don't initialize it, it gets some garbage values. Okay, first point. Second point is, when you do something like this is a variable that can store an address of a memory location where a struct can be stored. Okay, and right now it is storing some location, and there is no guarantee that the location, the value, the memory location value that is storing is pointing to a struct. So make sure that you point it to a struct before you use it, or set it to null if you're going to use it later. Okay, I hope this is not too confusing, and I have taken like memory for this local variable and this pointer in the same diagram, but all dynamic memory is allocated on the heap. Dynamic memory allocated on the heap memory. Okay, and all local variables which are not for example this is all on stack memory. Okay, local variables, okay, because this is a function, right, it has its own variables, local variables on stack memory, just remember. Okay, putting it all in the same memory diagram is just to make you understand things. Okay, all right, so difference between a struct object and a struct pointer is very similar to an int value and an int pointer. Okay, the idea remains the same. Okay, so I hope you like this video and this was helpful, and in the next video we see if we have a pointer inside a struct and then we have a struct pointer, how does that work? Okay, what are the details that go behind the scenes in the memory? Okay, we try to also initialize an array of struct pointers and we see how that works, dynamic array, because we have done some couple of videos on dynamic array memory allocation for 1D integers, single 1D array of integers and 2D array of integers. Okay, so let me know if you have any doubts, please mention it in the comments. I always try to answer all the comments, and you can also let me know in the comments if there's a question you want to solve or if the concept you want to discuss. So please like this video, subscribe to my channel, and thank you for watching.